All right, as we continue on with example 3, again, we're working out the problems, make sure we understand what's going on. And again, if you want to stop the video and work the problem out first to see if you can figure out what's going on and what to do, then let's stop it, and then we'll go ahead and go through and get understanding. Yeah, so it's not going to be that bad. And this one here, again, is not that bad. Now, again, the most complicated side is the left side here again, because you have two fractions going on, all that good stuff. So I'm going to jump back again to our rules, or guidelines, I should say. Now, again, number 2 says, look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator. Now, on this problem, example 3, you have two fractions going on. So we can add them, add the two fractions together, but we'll just have to make sure that we have common denominators to do that. That's the only way that you can add fractions. So here, we're going to add fractions. Because, it's always best to kind of combine them together and try to get things to cancel out and all that good stuff. So here, if we look at it, we have unlike denominators. So with this, we just can't combine them and say 1 plus 1 over 1 minus cosine theta. Oh, sorry, 1 minus sine theta, 1 plus cosine plus sine theta. I'm like, what's the cos part tonight? Well, right now. Right. So with that, let's go and take a look at it, and we're going to combine these two fractions or add them. But in order to do that, we have to have a common denominator. Common denominator. Now, the thing you have to think about is, how do you have a common denominator with this? How do you make it a common denominator? Well, what is our common denominator? And hopefully you just realize that that is 1 minus sine theta times 1 plus sine theta. So 1 minus sine theta and 1 times 1 plus sine theta. So how will we get that to both of those fractions to have a common denominator? And everybody should remember that. And I'm going to give you a thing over here really quickly. If we have 1 over 4 plus 3 over 7, how would you be able to combine those two? First, by finding a common denominator, duh. But how would you get a common denominator between these two? Precisely. Multiply this by 7 over 7. And multiply this by 4 over 4. And therefore, we would get 7 over 28 plus 12 over 28. And then we can add them up and then go from there. So if that works here for this, it will work the same way here. So if our common denominator is 1 minus sine theta plus 1 plus sine theta, sorry. If our common denominator is 1 minus sine theta times 1 plus sine theta, that means that we would have to multiply this fraction here by 1 plus sine theta on top and bottom. And then we multiply this side by 1 minus sine theta on top and bottom. So you can do that in the next step down here. So I'm going to rewrite this down here so you can see it a little bit easier, hopefully. One minus, sorry. 1 minus sine theta. The ends don't want to work right. That's going to equal this side, hopefully. Okay, so if we were to do this, we would have a common denominator of the 1 minus sine theta times 1 plus sine theta But on top, we would get 1 plus sine theta for the first fraction. It doesn't matter which way you write this denominator. If you do the addition part first and then the subtraction, that's fine, as long as you have them both down there. Okay, so at this point, we should be able to combine the two fractions together since they have the common denominator. So I'm going to do that really quick, and again, I'm doing this long out, like writing it all out. So if you can skip steps, it's perfectly fine to skip steps. All right, so here we have it written out. And again, let's go ahead and keep in mind what we're trying to equal this left side to. I'm going to write this down here so I can keep it visually in front of me. All right, so we should be able to get things to cancel out, hopefully. And so here at the top part, we can get our signs to cancel out, right? Let me change the color. We get our signs, the positive sign and negative sign, they cancel out. So on top, we have a 2. And on the bottom, we have this whole fraction going on, or a whole binomials happening. All right, so now we need to get to but we need to get to secant squared because we have the 2 already for this 2 right here matches this 2, but now we have to figure out how we're going to get secant squared. Okay, so with that, since we have this going on in the bottom, let's just try it. Let's just go and multiply. Let's just try it. See what happens if we multiply. And again, if we get to the part we multiply and nothing works out right, then we'll have to go back to this step again, the red step again, and then try to work something else out. So here, everybody should know FOIL or box method, whichever one you learned, because they both do the exact same thing. Just one is more visual than the other. So if we FOIL this out, we have 1 times 1 is 1. 1 times positive sine theta. It's a positive sine squared theta. Sine theta, sorry. Negative sine theta times 1 is negative sine theta. And then negative sine theta times positive sine theta is a negative sine squared theta. So it squares. Okay. So at this point, we FOIL it out. We should be able to see that things cancel out again. So our sines cancel out again here. And we're left with 1 minus sine squared theta. And again, we have another trig identity that does with sine squared and 1. And we've been hitting this the past couple of examples. So hopefully everybody already knows what this one is, what this equals to. Again, we have this. And again, if we subtract if we subtract sine squared from both sides, we get cosine squared, which is what we need, right? And again, this ends up being difference of two squares type thing, or nah, never mind. No, not gonna say that. Not gonna say that. All right, so here, again, we already know that our 1 minus sine squared is what we got when we multiplied our denominators together, or our denominator together. That gave us 1 minus sine squared, and we said that cosine squared equals 1 minus sine squared. So here, coming back up, we're going to keep that 2 on top, but we're going to say cosine squared theta. And again, we're trying to see if it equals 2 secant squared theta. That's what we're trying to get to. And hopefully you can look at it and be like, okay, we're done, we're good. But if you can't, it's okay. Again, we're going to go back to our trig identities. We know that when it comes to secant theta, that is 1 over cosine theta. And again, if you do the squares here, it's the same thing. If you do cubes, the same thing. To the 4th power, the 5th power, 6th power, it's the same thing. So here we have 1 over cosine, which if you want to, you can say this is 2 times 1 over cosine squared. So if you have that, that means here we can rewrite this as 2 secant squared theta. And that equals this side over here, which is 2 secant squared theta. Oh my gosh. We did it. Lovissima again. Yeah, we did it. Lovissima again. Yeah, we did it. Lovissima again. Yeah, we did it. Lovissima. Yeah, we did it. So we made it to the end. And again, this one took a little bit longer, and it's okay. It takes time to do some of these. So you can't be in a rush. And you can't just be like, I just want to get the answer, because you might not get the answer that way. But again, take your time through it. And if you get stuck, it's always okay to ask questions and get help. All right, so here we go. Good job.